Okay. So hello everybody. Welcome back to the second session of Hitchhiker's Guide to Nextflow. So this is the PM session, and it's going to run from now until 2 p.m. So once again, I wanted to begin by acknowledging that the land on which we gather is the traditional, ancestral, and unceded territory of the Musqueam people. And I hope that by coming together and learning and sharing together, we can move towards truth and reconciliation. Okay, so all of the slides and the content that you see today is copyrighted by CC BY SA 4.0, which is a Creative Commons license that allows you to share and copy and redistribute this material in any way that you wish, and also to adapt the material for your own uses in the future. The only thing we ask is that you give attribution where necessary, and that if you do reproduce this material or adapt it in any way, that you use the same license as this content. Okay, so the PM session is primarily going to be looking under the hood. So we're going to get into a little bit of the nitty gritty. So it's going to get a little hairy. We're going to be looking at a lot of code. I know code doesn't present very well on slides or in presentations. So I have some content prepared, but near the end, we'll probably go into a little bit of a live support session, and people can try to stand up their own NF core workflows for things that they actually intend to use, and then we can work through that together. So I think it'll be interesting. As before, this is the code share. So I think we may or may not be pivoting away from the code share. So if people have a lot of questions, it may be better to type them in the Slack, and that way they can be, we can keep up with them and answer them kind of in place. In terms of TAs, in person we have Phil, and then online we have Selene and Oriel. So message them if you need help. Okay, so a high-level overview of what we're going to be doing for the next 2 hours. So we're going to go through the run that we just executed on PBS Pro. We're going to look into the files. We're going to look into all the different reports and the outputs just to understand what's going on. And then we're going to go into Nextflow. So I'm going to talk kind of briefly at a high level about how Nextflow works and the model that they use in terms of mental organization of how things work. Then after, we're going to do a little bit of a DIY. So I wrote a significantly smaller RNA-seq workflow that does something similar to what's implemented in NF core RNA-seq. So we're going to look into that, and then I'll show how those are similar and how, in theory, you could write something on your own that doesn't have to be monstrous like the .nf that we looked at earlier. And finally, we're going to compare how those runs look, how the configuration is different, some commonalities, and I think that'll help everyone kind of understand how the configuration and how the different workflows fit together. Okay, so in the first section, we're going to review what we ended up making, what the run produced. So before we get into that, if anybody's jobs, oh, sorry. Drop it into. Okay, so like I was saying, in the event that your job failed, one of the cool things about really any workflow language is the ability to resume. So this is why you wouldn't want to write a large pipeline in something like Bash or just in some script, because those always run top to bottom, and there's kind of no intelligence about where something failed, or if there's kind of an insertion point where you can just get back in because, the intermediate files are okay, but then it's intelligent enough to know that a specific process failed. So Nextflow obviously has all of that implemented, and it has a very thorough caching feature that lets you resume a job from any previous point of failure. So if your run actually didn't work, it'll actually give you the command that you could copy and paste, and it'll say like, you can, if you have sorted out the problem, you can type this to resume. And essentially it's just to add this resume flag. And if it's able to resume and it's cached properly, you should be able to get that going again. So I did want to kind of get into how the caching works because it's important for some later points. But if you go into the directory where your run successfully executed, you'll see a new directory called work. And this is where all of your little processes executed. So if you are brave enough to go into that directory, you'll see that it's actually a not very user-friendly hash organized directory structure. And this is how Nextflow isolates individual jobs. So each folder deep inside this work directory is where a single process was working. And that's where the inputs would be symlinked to, and then the outputs would be printed, and then those outputs would be symlinked into some other hash organized directory. And that's at a very high level how that works. So if you didn't get a successful run, or you didn't get it to run at all, or you just wanted to see what the outputs look like, I have example outputs from a previous successful run of mine on the exact same data, so it should be very, very similar. So you can grab that if you do this copy command here. Alternatively, if you got a successful run, I really encourage you to just look at your own reports because you'll be more familiar with your own data. So if you look inside this directory, inside this NF-core RNA-seq out, you'll see outputs from all the different workflow steps. So we can peep that here. So if you see we're inside this, well, I guess I'm cheating because I'm in the project directory. But this is the NF-core RNA-seq output. So if you look, there's going to be 5 folders in here. And they kind of correspond to some of the major steps in the pipeline. And where we want to look first is this pipeline_info directory. So if we look in there, you'll see a bunch of HTMLs, some text files, some traces. So what you are interested in is going to be the HTML files. So these are really nicely produced and summarized results about the technical aspects of your execution. So if you have SEP set up, or you have SSHFS or something like that that allows you to pull this file, then you can download it and look at it yourself. If you don't have that set up, I did in the Slack upload 3 of the HTML reports that you can use to take a look at what these reports look like. So that's where we're going to start. So, oh, is it? Oh, okay. Okay. All right, a little bit slower. So Nextflow will generate 3 different reports by default. So there's an execution report, and this is kind of the high level technical details about how the run went. You'll get a timeline, which is kind of like a Gantt chart that shows time on the x-axis and then the different jobs on the y-axis. We're going to look at all of this. And then a directed acyclic graph, or a DAG, and this, depending on how many processes are involved in your pipeline, can get kind of get to be a tangled mess, but it's interesting to look at. So let's get into that. Okay, are we synced on Zoom? That's what I mean. Now we see. Okay, all right. So this is the workflow report. So you can see that 129 of the jobs actually succeeded, but you will get, or you should get, 4 tasks that reported an error and were ignored, and then 4 tasks should have actually failed. And we know why this happens once we dig into it. You can also see the command that was used to execute and all the directories that you use to run them. And here you see really nice interactive plots that show you your resource usage here. So this is CPU usage at the top, and then your memory usage at the bottom. And this is what I was talking about before, where sometimes you just don't know what kind of resources a specific job will need. And this is your opportunity to kind of look into it and optimize if this is something that you're going to be running a lot. So you can see the raw usage on this first tab here. But if you look at percent allocated, you can see how much of the resources that you said or you thought that a tool would need versus how much it actually ended up consuming. So obviously you want everything ideally to be about 100% of what was needed. However, I will say in NF Core, for lots of these workflows, the resources are specified by the workflow itself, and it's kind of internal. So if you really, really wanted to, you can get in there, if you read the documentation, to modify the specific resources for specific processes in order to really tweak how many CPUs are needed, or how many CPUs are allocated, or how much memory is allocated. But again, this is not a good example to optimize because the data is significantly downsampled. So it should have been pretty easy to process. So yeah, that's CPU usage there. Mm-hmm.
So much of the memory, so you can manually set up to offer star more memory in the Nextflow pipeline.
Exactly. Yeah. So that's the next example. Yeah. So here you can see everything in terms of memory load is fairly low. I guess, what is this? Oh, Picard Mark duplicates. It took 10 gigs of memory, but the kind of biggest culprit here is star align. And we know that because star loads the entire genome reference and the index into memory, so that it can work quickly. And if you look at the percent RAM allocated, however, it's actually only half of what the Nextflow people thought would be necessary. So it looks like they allocated probably around 70 gigs, considering it's like 72. Yeah, so this is like 35 gigs. So if, let's say, you have like really thin RNA-seq samples for some reason, and you really don't need, all the runs that you've done don't need more than like 35 gigs of RAM for whatever reason, then you could go in and tweak this so that your jobs, in theory, should be scheduled more often because you're using half of the resources for this specific step. So that's something that you could do if you really wanted to optimize. And then this is job duration. So you can see how long each step took. So most of these took less than 30 seconds. The only thing that took some time was the star align. So this is how long an individual process took. But when we look at the Gantt chart in a bit, you'll see how they were kind of staggered, and that's why the total runtime was longer than that. Okay, and then I/O. So I think you had a question about I/O earlier, where like if you have tools or processes that require a lot of read-write, this would be a place where you can see that being a problem. So here you can see star did require a lot of reading because it was loading the index into memory. And similarly, it should, oh, it doesn't actually, oh, I guess because the BAMs are quite small, so it didn't have to write that much. But yeah, so yeah, if it was, yeah, if you had like an actual full library, this should be quite large because this will probably correlate pretty well to the size of your BAM. And then this was the FASTA cleanup. So this did a lot of writing in order to kind of do the trimming and all those things to create the FASTAs that end up being aligned. So that's where you can interrogate your I/O requirements. And then finally, the last thing on this report is going to be this large tasks table. So this is a big table that summarizes every single process that was run. You can see these are like fully qualified process names. So this is to prevent any kind of confusion within Nextflow or within, NF Core. And it's actually these process tags, these full process tags that you would need in order to modify the resource requirements of some specific process. So for example, if you wanted to change the star line, is this star line? Yeah, so you wanted to change star line, you would need this kind of fully qualified process name, and then you would put this into your config, and you would change how much RAM was called for this. So that's how you can use this. And then similarly, you can always, it's like any other tibble, you can sort them by columns. And here you can see the 4 jobs that failed. And you can see that all of them that failed are this pre-seq LCEX trap. And I believe this is a tool that attempts to rebuild transcripts. So it should fail because the toy data that I grabbed, it's actually just a very small segment of the genome in chromosome 2, and it just grabbed reads that overlap that small window. So there's probably a lot of broken reads in, I think. So this is one of those things where if you know in what order or what the dependencies of the various processes are, you would know like which jobs are kind of like mission critical and which jobs are kind of like they produce some output, but if it fails, nothing waits for that output as input. So it would kind of fail in this way, and then the rest of the jobs would continue. So as an example, if this failed and the star line failed, then nothing afterward would run because you have no BAMs, which means no bigwigs, which means no quants. Yeah, exactly. Yeah. So that's how you can read this report. Okay. Okay, that's a good question. So the question was, is this report generated by any Nextflow execution, or is it only an NF core? So this report can be generated by any Nextflow execution, but by default, it is not created. So we can get into the command line parameters that you need in order to generate this report. But by default, NF core does generate it and puts it at this location. But yes, if you run your own Nextflow or you write your own Nextflow scripts, you can add a flag that will generate this really nice report for you. Yeah, but it's something that you have to specify. Oh, you don't see the report? Are you looking inside pipeline info there? Okay. Yeah, so it should, did anybody else try to look at? Yeah, so there should be like 3 HTMLs, a trace, and then your sample sheet CSV. Okay, yeah. So maybe your run failed, or we hit a file limit quote again.
I have a sample sheet.
You also don't have HTMLs? Oh, interesting.
You could have been looking at the output.
Interesting. Okay, yeah, that might be something I have to look into because I don't see. So normally you would put it in your config to specify that a report should be generated, but I thought I did it by default. So maybe it's something when we changed how the execution works. But I'll look into that.
Like it's something with the next one.
Maybe. Yeah. Okay, yeah, but yeah, these reports can be generated on any Nextflow run. Okay, so this is another cool report. So this is kind of a process execution timeline. So it shows you all the processes that ran and on which kind of inputs it ran on. So here you can see time is kind of running along the x-axis, and then different jobs are in the order of their scheduling, not execution. They're coming down on the y-axis. So everything in color. So each process that's the same is the same color. I think they ran out of colors, so it's starting to duplicate. But everything in color is the actual runtime. So it's like using cores, using resources to process. Everything in gray is wait time. So this was submitted to the scheduler, but it didn't execute until this point. And then anything after that is gray is the cleanup. So either it's copying files or it's, shutting down the container, things like that. So that's where you get the gray afterwards. So you can see how the jobs kind of cascade as resources become available. And then you see these 4 big ones are the alignments. And yeah, they all go down to here. Yeah, so the color means that's the time period where the job was actually executing. So it's actually processing your samples. So it's basically doing what you told it to do. When it's gray, it's just waiting.
Okay.
Yeah. Yeah.
It is a flag
Dash with dash before.
We
Okay. Okay. Yeah, so I guess you do have to specify it in Nextflow. Okay. And then the last one, so this is the directed acyclic graph that kind of summarizes which processes were ran. So this is all in JavaScript, and it's actually, you can move things around. Sorry? Oh.
That seems like a kind of routing side of things.
Uh-huh.
Then organizing the
Yeah. Yeah.
quite a graph.
Yes, this is quite a graph. I don't know how useful it is, but if, when you're writing your own, I think it's not going to nearly be as convoluted or crazy, and it might be more useful for kind of troubleshooting what's going on. So that's that. So these are the 3 kind of basic reports that you would want to take a look at if you're interested in the technical performance of your run, and if you're looking for opportunities to do resource optimization, or if you want to fix how your jobs are scheduled, if you're looking at that timeline. And this is very useful for, in some cases where you are like running data that's output from a few channels, but you require all of those outputs for some specific process, then you might see a lot of wait time, even though resources are available, because the process needs different files. So in those cases, there's not really much you can do. But in other cases, you may be looking for pairs of samples, but those individual samples are not being run in some specific order. So once 2 pairs are created, you may want to just process those pairs. And that's something that is not as intuitive as I hoped it would be, but it's something that you can code so that it's always looking for like, file A came out and I'm looking for file B, but then it's working on like file C and D and E, but then finally, B comes out, but then it's not going to wait for all the other files to come out. Once it has A and it has B, you can get a process to spin up. So things like that, maybe like opportunities for optimization. Yeah. Mm-hmm.
Where you said that the gray was the wait. Is this wait time including the time that it takes to get the resources all to the file?
Yes. So this is what the wait time is. So this is basically Nextflow. So the inputs to your process are ready, and the job has been submitted to through QSub to PBS Pro, but the job is not running. So it's all the wait time that it took for the actual execution to start.
So this wait time is only the wait for the resources to be allocated, or does it have something else?
Oh, well, I mean, if you have things where you need to like spin up containers, or you're like loading up environments, or in some situations where I didn't have the iGenome set up, I actually don't know, because I think it calls another workflow to download the iGenomes. But if it didn't, that would be like included in like wait time, like things like that. Yeah, like all this setup.
We did find the pipeline info, so it's stored in null/pipeline. So the HTML do get put out. Right.
If it's in null, I might have misconfigured the config. That's what happens when you don't have a proper output directory, I think.
Oh, okay.
Yeah, so it shouldn't be in null. Yeah.
Well, that's where it is.
Yeah. So if you, I think this might be one of those things where, because outdir is supposed to be specified, or like they always specify at command, at runtime in the command line, instead of in a config. So I wonder if it's one of those like parsing order things. Yeah, because it is in the config, but it doesn't seem to be interpreted. So yeah. Okay, so that's where we are with that. Just make sure Zoom catches up. Okay, so after you look at the technical performance of Nextflow, you're probably interested in the actual data, which is what you went through all the trouble for in the first place. So yeah, those of you who work in bioinformatics, you're familiar with tools like multi-QC. So it's just an aggregating QC report tool that collects all these different QC modules and puts them into a very nice HTML report. So we can use this to peep the quality of our significantly downsampled fast Qs and BAMs. It's here. Just give it a second. Okay, so as you can see, this is a very, very thorough and large report with every metric you could hope for. So I'm not gonna work my way down through it, but I'll do some highlights. So here, this is that that one module of DSeq2 that was executed. And as you can see, it just did a PCA, and then it did a heat map of the sample to sample distance, just to show, if you have, two samples that are, they should be like technical replicates or biological replicates, and then, you have a treatment, and then you can see maybe from the PCA already that they're different. But if they're not, I wouldn't fret. There's a lot of normalization and things that need to happen. So this is just a very quick overview of your data before you even start to analyze it. Yeah, no, it's not correlation. It looks like it's like a sample distance, like a distance matrix. Yeah, something like that. Yeah. Okay, so Picard doing duplicate flagging. You can see these are very low duplicate libraries. Maybe we can see how many reads we have. Probably. I mean, there are like a few genes in here. Yeah. It's really cool. Yeah, so then your mapping percentage of all the reads, as you can see, how many reads you had. They all mapped because they were back calculated from a BAM. You have, yeah, alignment scores.
What is the data?
This is the GeoVatus RNA-seq. So it's like four of the libraries that had pairs from the 1,000 genomes, or it's like paired with the 1,000 genomes libraries.
And how did you track the RNA-seq?
Yeah, so I think I used SAM tools to view a window, and then I grabbed those reads, but I didn't realize at the time that when you grab reads using SAM tools view, that it doesn't grab like the pairs. It's literally any reads that are in that window. So then originally I was getting a ton of like QC failing, and it just wouldn't even move through the pipeline because it thought like your like fast queues are broken because they should all be paired. So then, yeah, that's why there's that one flag, if people remember from morning session, where I had to say like the minimum number of like high quality reads is 1 and then just run it. Yeah, so that's something that needed to happen. But yeah, you don't need that if you're actually running. I think the default value for that is like 20,000 or something. But it's not even 20,000 reads in these libraries. Yeah, so then here you can see this fails per base sequence content because of an imbalance in nucleotides because of random hexamer priming, and there's just a bias in like the nucleotides you're going to see here. So this is a common thing if you look at a lot of RNA-seq. So yeah, this is just your typical QC for RNA-seq, and you can dig through. I think, yeah, so it actually has twice the normal number of reports because it runs the entire thing again for your trimmed reads. So that's what you're going through all over again. So that's that. Okay, so now you know how Nextflow did. Now you know how your data quality appears to be, and then we're really here for these, assuming all of those look good. You want your output files. So the whole point was to get your transcriptomic data. So the workflow, like we said earlier, is designed to create these files. So you're going to get your BAM file, which is your binary alignment, and it's going to be indexed and sorted. You're going to get a bigwig file, which you can view in some kind of genome browser, and then your gene expression matrix, which is probably what most people want to kind of dig into, like differential expression, to see like your treatments and things like that. So we're going to look into that, and that is all inside this star salmon directory. Yeah, so these are the files, and then inside pipeline info was your reports, and then inside star salmon right here is everything. So these appear to be most of the outputs for your alignment, and then also the salmon quants will be inside those directories. So if you want to look at the BAM, yeah, for those of you who have never seen a BAM before, this is like the name of your read, and then this is where it aligned to, and then a bunch of, I think these are like, there's cigar strings and some of the things about like the length and then the map quality. And then these are the reads. So these are those reads that came out of the trimmed and processed fast queues. And the duplicates flags, they're all in there. Yeah, so that's an error. Yeah. So there is the first read is mapped to chromosome 1. No, so it should just be 1. So it looks like these like 20 odd reads.
Non-unique map.
Yeah, non-unique map.
Yeah, so when you cut reads out of a big window, read map multiple locations, then you probably just randomly picked, a read that mapped to that appropriate to the window we took.
Yeah.
That happens anytime you read map.
Mm-hmm. Yeah.
You show us ad of the
yeah.
Count. Oh no, just like counts.
Oh, just see the counts? Yeah. Yeah, so I was gonna go into there. So this is like one. There's a merge count?
Yeah, right. In the directory there.
Oh yeah, look at that. This one.
That scale, you can do gene counts.
This one. Yeah. So yeah, there you have your gene IDs, and then the 4 libraries are all here. So this is basically that matrix that you would want if you're going to parse it in R. And I think I saw an RDS in there. Yeah, so there's like R data serialized objects. So these things can be parsed directly into R. And I think this is probably going to be some kind of data frame or matrix. Yeah.
And that's where you start.
Mm-hmm. Yeah. Yep. So on Tuesday, you'll be looking at this, and then you're going to kind of take it through all of the RNA-seq analysis. Yeah. So now you know how it starts from off the sequencer.
You sort that count.
Yeah. What was that? Like the 3rd row? Yeah. These are not even the normalized ones. Yeah, DNMT3A. Okay. Yeah, so those are all the things that are in there. So those are your counts, those are your BAMs, and then I think, oh yeah, so there's like per sample quants inside the individual directories. It's not going to be in there. Oh, it's going to be, there you go. So those are your bigwigs, and you could put those, you could load those into a browser if you want to see your coverage. Okay. So now we're going to get into how Nextflow actually works. So really, I think it's important to like think about what problems a pipeline solves. I think we addressed this pretty directly in the morning. But the idea is that like any kind of pipeline, any kind of like analysis process involves using a number of tools to kind of get data from one place to another form that you desire. And if you just do this by hand, it's really easy to like forget parameters or to forget outputs, and then you mischain them together. So kind of the whole point of writing a pipeline is that you can sort all of this out once and then have it kind of parameterized and written out explicitly. So if you have outputs from one step that are going to be inputs to another step, they're linked in a very formal way. If you want to run a specific step in multiple ways with different parameters, you can set that all up in one place, and you don't have to just press up at your command prompt and then modify like one flag and then lose it forever into your history. And then yeah, obviously some steps may be more resource intensive than other steps, and this is one of those places where using a workflow language really helps. So you can, as you'll see, specify resources for specific processes, and that's exactly how NF-core RNA-seq does that. So it, for STAR, it knows it's going to need a ton of RAM. It knows it's going to run for a longer time, so it might use a longer kind of kill window for the job before like it thinks it's stalled. It might give it kind of more RAM so that it doesn't get a like out of memory error. But then for other smaller things where, I don't think aggregating a bunch of like multi-QC QC reports is going to be very resource intensive. So that might be like a single core job, right? So those are things that you can very easily specify once in a workflow, and then you're not kind of playing around at the command line with the various tools. Okay, oh yeah, so the main way that Nextflow kind of simplifies this way of thinking is to use a channel and process model. So fundamentally, all the pieces of any Nextflow workflow are just channels and processes. So in a schematic, in this channel, you just have a big queue of data, and that is all that a channel is. So channels can be manipulated. You can duplicate channels. You can go in a channel and pair up data, but essentially a channel is just going to be a queue of objects. These can be data. These can be paths. These can be literal values like strings, numbers, things like that. But that is all that a channel is. It organizes data in a way that is parsable by a process. So a process is just a specification for how a tool should be executed. And this is where you could really write it in any language that you want. So you could have the code right in the Nextflow. You could write a script and then call that script from within this process. There's lots of ways to do it. But this process is essentially responsible for looking for inputs from a specific channel. So once a channel is populated, the process knows that all the inputs it needs are ready. Then it will ingest that and then execute it and then output those to other channels. So channels feed processes, processes feed channels, and then goes on so forth until all your data is processed. Okay. So processes, these are single steps in the workflow. So if you think back to that kind of cute little subway schematic that NF-core RNA-seq had, each of those nodes would be a single step in the workflow, and they would be defined by a single process. So it's important to know that all processes are independent. So each one is going to run by itself. It cannot depend on any other process it cannot expect to be able to communicate with any other process or to write data between them, because processes, as you saw in the timeline, they run at their own time when resources are available. And you can't expect for process A to be alive when process B is going, and then to expect to go into its files and like look for something. So the only way that processes should communicate with each other is through channels. So this is really, really, really basic syntax for any process. So I should mention, Nextflow is written in Groovy, which is a flavor of Java. So that's why you're going to see a lot of curly braces, lots of colons and things. But this is the basic syntax for a process. You're going to say, just call process, then the name of the process. And inside there's going to be a section called script. And script is essentially where a string that will be interpreted as a command will be executed. So if you don't specify like an executor like PBS Pro, this will just run locally. And that's how that works. So what about inputs? So processes that also define, they can also define the inputs that they expect, as well as the outputs. So if you expect to take in something in order to execute this process, you would specify it up here. And then based on what's in here, the process will be watching these channels for things to come in. And once a full set of inputs is available to any given process, a new instance of that process is spun up. And that is essentially how processes know when to start running. So all these inputs that you specify, once there's at least one item in every single input, one instance of the process will be submitted or scheduled. Okay. So channels. So channels will organize the data, and they allow your process outputs to be connected to other processes' inputs. So because channels are their own entity, you're actually able to manipulate channels in between processes to do some really, really cool things. So this is how you can get data aggregated. You can duplicate the channel so that you can run, in this example, like task beta, like a few different ways with the same inputs just by duplicating this channel, for example. Or you can run them in parallel, right? So like I said, things that are in a channel can be any of the things that Nextflow expects. So these can be entire files. They can be just paths to files. They can be actual values defined inside the script. And you can think of these channels as a queue. So all the files that are in a channel will be processed in the order that they enter the channel. So it's a kind of first in, first out model. However, just because an item in a channel is quote unquote processed and the job is submitted, again, because of the way scheduling works, it's possible for something that came out of a channel later to finish first, simply because of the way, however the resources got allocated, right? So again, this is one of the situations where you can't expect outputs to be in a specific order, and you also can't expect, if you don't export a file into a channel and you just write the file somewhere, you can't expect a process downstream to just read the file at that path. It should be in a channel so that Nextflow explicitly knows when the file is ready. Because, task A could, if it silently writes something to some path, and task B is expecting that file there, it's entirely possible that, when task A is scheduled, some other file that is already processed by task B is looking for this, and it doesn't exist.
Generate an output, and you want to keep the next step, you have to fix this.
Yeah, so if you're creating an output that is required downstream by another process, you absolutely need to put it in a channel. That's like the only reliable way for files to be where you expect them to be. Yeah.
Does that doesn't apply for things like referencing? Like a new file could be considered not in a channel because you're not waiting for those references.
Yeah, so in the Nextflow documentation, they kind of split channels into kind of two different types. So there's like a true queue channel where the queue can be empty and then it's populated by things that are being output. And then there's other types of channels that are called like quote unquote value channels, but they're really just like a queue of like infinite length. So it's just like, if you have a reference, it's always going to have a reference at that place. And no matter how many references are consumed by some process, you're not going to run out of the reference. Yeah. So it's a nuance in how you declare the channel. Yeah. But that is, yes, that is something that you should keep in mind. Okay. So channel declaration, there's a ton of ways to declare channels. If you have like just values and you want them in a channel, this is like the most basic way to do it. And just as an example, it's easy to understand. But there's tons of ways to create channels. So if you look in the documentation, let's say like you have a folder full of like fast queues that you want to process. If you use like a specific version or what they call, they're like methods, channel methods to like parse that directory, you can build a Nextflow file object for every single object within that directory, and then put it into a channel all in one command, right? So like things like that make it very powerful and like very syntax light. But those are things that you need to dig into the documentation for. But essentially, all channels will be written something like this. They're saved to some variable, and then processes can consume channels once they have a matching, as long as the channel kind of provides a matching input. Okay, so this is kind of the smallest possible example. So inside your Nextflow script at the bottom, you'll have a declaration for workflow. And this is kind of the high level master, like it's going to go here and look to see what needs to be run. Okay. No, so this workflow is only going to be specified once. And yes, yeah. So I've color coded everything. So if it's orange, it's like relating to a channel. If it's green, it's related to a process. Yeah. So this is a process that's consuming this channel. And this channel is a channel full of strings. Okay, so if you remember, so then that means that CH_MSG must contain like string values, right? And then if you look inside print message, which is what's being called here, you can see that it expects one input, and that input is a value, and it's going to name it message. Okay, so I know it's like, yeah, teaching code on PowerPoint is not ideal, but just to give you an idea of how these things come together, it's really just this simple. So then once you have, you know, an emission from this process, so like you have an output, then that output could be named and then put into another process, and you would just have a string of processes in here, which we will see in a second. Yeah. Yeah.
And then every input, you need to make it into a list to put it in as your argument.
Yeah. So yeah, you can think of that. So like every argument to this function would be parsed like one at a time. So if you had multiple arguments, which would be like multiple input channels, they would all be like, you know, it would take one from each and then spin up a job for that. And then it would take another one from each until one of the channels goes empty. Then it stops. Yeah. Yeah.
So there, for example, you have the process. And in this case, you only have one, right?
Correct.
So the way to have an input process, I guess you would have a channel with the message with that input. But then, does it have to be like the channel should only have that input, or can I use another channel that has this input and other value for different processes?
Okay, that's a good question. So can you have like a channel that just has like one matching input for this, but then if you like feed that channel to multiple processes, if it's like smart enough to know, like to process the input that matches? Yeah, no, so it cannot do that. Yeah, so that is something that you'll need to do to like manipulate a channel. So like this is a very common use case. So you have like fast queues, right? So the fast queues have some sample ID, right? But you want to pair that sample ID to some metadata. right? So you can extract like this, the sample ID from that metadata. So now you have a string that is your sample ID, and then an actual file object that is the FASTQ, right? So if you feed that into a process and the process is only expecting FASTQs, it will like crash because it doesn't know what to do with your sample ID string.
I think so channels have to be tailored to be processed in the sense that the input have to match the exact number.
Exactly. Yeah. So this is the thing is you can have, so again, this is like in the documentation, but there are things called tuples, and tuples, like if you know, basic programming. So then like you have one object that contains like a few things in a container, right? So you can parse out a tuple as a single output from a channel. So a channel can be full of tuples, but that tuple has like, in this example, your sample ID and your file. So when you parse that single tuple in here, you could specify under value that it's not a value, it's a tuple, and that the tuple has a value and a file. And that's a single object. If you have more lines, then you would need more channels. So if you have an input, so in an opposite example, if they weren't tupled, you could have value, sample ID, and then file path to your FASTQ. And if those are in 2 lines, then you need 2 channels.
In the 19 slide, question is, so I'm not going to get it more later, but this channel declaration.
Mhm.
For example, you can keep a channel that off.
Yeah, so this is say like make a channel of these objects.
Okay.
Yeah,
Okay.
so these 4 strings are now in a channel, and the channel is saved to this variable. And then this variable is just fed to this. Yeah. So this is really, I guess, this is like a single use at the beginning where like you are parsing like some like sample sheet or something like that, and you're just building out a channel for the first time. But once you start parsing these and you have an output here, you would actually need to name that channel on creation, and then you can refer to it in here.
Be more clear.
Yeah. Yeah. So we're gonna get into it. Okay. So we're going to now write our own Nextflow script, sort of, as in I already wrote it, and we're going to go through it together. So this is my cute little attempt at a similar kind of subway style station schematic of how this mini RNA-seq workflow works. So here, this is actually something that I needed for a project, but here I only needed HiSat2, and then I needed to mark the duplicates so that the feature counts could be, duplicate aware, and then I just wanted a BAM coverage call so that I could look at the coverage in a convenient visual form, right? So this is a really, really simple, actually like four different tools being used. And then it's just that this tool is being called in 2 different parameters. So again, this is one of those ways where you can use a channel twice. Okay, so you can also see in terms of outputs, these are the same. So I still get a BAM. I'm still gonna like inside it's still doing indexing, it's still sorting. I'm still getting feature counts, this TSV, and I'm still getting my kind of bigwig. So not all Nextflow scripts need to be 1,000 lines. Yeah, so this is, scaled down version, same basic steps, but the payoff here is that it's going to be a lot less flexible, right? So the point of having 1,000 lines is that whatever genome version you want, whatever aligner, as long as they have it like implemented, whatever QC you're going to be running, all of those things are options to you, right? But in my workflow, the outputs are still going to be the same. I'm still going to get the BAM that I want and the gene expression that I'm looking for and my coverage, right? Okay, so before we move forward, I want everyone to grab a copy of this mini RNA-seq workflow and move it to your student space. So this line here should do it, and then that'll take you inside. And I just want everyone to take a look at the Nextflow file. So all Nextflow files have a .nf extension. Okay, so everyone should see something similar to this. You see everything in double slashes are comments. Obviously, I always document all my things to this thorough degree, and it's not only for show because people are looking at my code. But you can see at a very high level kind of like how things are organized. So at the top, I've got my channels. I build channels from my inputs, and I've got kind of, well, actually 2 channels here. And those channels are being manipulated with a join command to get my FASTQs paired. So this is something that we'll look into later. But this is one of those things where I'm just manipulating channels in order to get them into the shape that I want so that I can process them in a way that makes sense. So this entire thing is just to pair my FASTQs with a sample ID. Then we're into the processes section, and every single one of these is just documented at the top, good old CPSC 110 style. Inputs, outputs, and then what it does. And you can see this is how structurally it looks in general. So you'll have your inputs, and so you can see here already, this is a 4 input process, and it has a tuple that contains 3 things. So one of these is a sample ID, 2 of these are paths to my paired reads, and then it also needs all these other things, and these are actually, well, this is a value channel, but there's some fancy stuff going on here in order to get the actual HiStat index directory, but then also the root name of the HiStat index, and then the path to my splice sites and all that stuff. So in terms of the script, you can see it's going to run that, and then I guess it's not best practice. You should write a new process for this, but I'm secretly doing my SAMTOOL conversion to BAM and sorting all inside here. And then the main thing is this output. So you can see I'm creating this output, and it's going to look for a file that matches this form. And if you think back to that work directory that I was talking about earlier, because each process, so when a single instance of this aligned FASTQ is spun up for a single pair of some FASTQ for one of those 4 samples, it's going to happen deep inside that work directory inside one folder, right? So when it writes out a file, it's just going to produce that like sample ID, so like HU0010 underscore sorted.bam, just in that work directory. So what this tells it is to find that file and dump it in a channel called align BAMs, so that whatever needs align BAMs later will know that one exists here. Okay. And there are just.
So if you're this map.
Yeah. Map.
Line map.
Yeah.
You put multiple commands into a single process. Likely because all those processes use similar resources.
Yeah.
But you could have also split those out into 8 processes and then SAMTOOL view and sort within their own processes, channels.
Yeah, absolutely.
Advantage doing it like this, like.
I don't know if this is like the official, like from what I know, if you think there's going to be a lot of overhead with spinning up new processes, I think because you're already in a process with allocated memory and things like that, and it's not going to be a lot of like additional processing, I think it's fine to do it this way. It could be a little harder to read because if you're looking for like, oh, where's my BAM conversion process? Like it doesn't exist because I've hidden it inside align FASTQs. But yeah, so best practice if you're going to be doing this a lot, or like those jobs are going to be really heavy, it's like better to split them out because you may also, if you need variable numbers of resources and things like that, like that's how you would be able to specify it. So here I can't specify different resources because they're all under this label, which we'll talk about later. Yeah. Yeah. So here we're in a mess of processes, and then at the very bottom is a single workflow call. So some people were asking about this. So this is the single workflow call that tells Nextflow what I actually want done. So all of these, like Tiffany said, are like, you can think of them like calls to the function that are the processes, and then the channels that I've already built, and then also some like at runtime parsing of the parameters. So this is, all those command line config things that we talked about. This is where they come in. So when you call a params dot something, this could have been a dash HiSat2 underscore splice sites that's parsed at command line, or it could be a HiSat2 underscore splice sites equals something defined in your config. And this is where those variables all come in.
So the file that you're loading for params, those indexes, those are in the infinite channels, or those are not even in channels?
These things,
Yeah.
These are like not even in channels.
Okay.
Yeah.
So you can use data on the system without it being.
Oh, sorry. So this, yeah, I'm like, so these ones are actually, they're a file object in Nextflow. So it takes this, and then you feed the file function a path, and it'll parse that into a file object. So when it's fed to align fastq, it knows that this is actually a file that it can read. Whereas this will be read as a value. So this is just the root name of the HiSat index. And then it knows to look for these indices and then the corresponding extensions inside here. So this is actually, I forgot how fancy this was, but it uses globbing to grab all the index files that are rooted with this name actually. So it uses the param to glob all of those into a channel that contains all those files. Yeah.
With the spline sites, it's just a single file.
Correct. Yeah. Yeah, so once you have globbing, it'll intelligently grab all those files. So like I was saying, if you have a directory full of fastqs, I don't think you would use this command, but you could do something similar to turn all of those into file objects and then dump them in a channel. Yeah. Yeah, there's a lot. So then if you remember that one thing I called out, the align underscore BAMs, so that was an output of align fastq. And this is how you can chain channels in a very explicit way. And this is actually something I like about Nextflow because in other workflow languages, sometimes these things can't be explicitly defined. And then it's up to the workflow interpreter to figure out how everything is connected. And that can be a real nightmare. Okay. Okay, so before we really look at the code and figure out which pieces of the pipeline they are, I just wanted to say that obviously this workshop is not going to be your be all end all workshop for learning Nextflow. I'm also actively learning it still, and there's tons of things that I'm discovering every time I write a new workflow. So in terms of good starter guides, obviously all of these are in the docs. So these two are in the root docs in nextflow.io. There's a great little quick start guide that shows you how to get a really small Nextflow script going. And then this link is really great. So this takes you to a list of tools that basically shows you all the different ways you can manipulate a channel. So I think one of the ones I was using is join. So they're all classified into different types. So if you want to, after something's being run, you want to take things out of your channel, you can use filtering operators. Or if you want to turn your channel into two channels in a very specific way, you can use splitting operators. So I used join because I had fastqs and sample IDs, and I was using them to combine two channels to get paired fastqs. So that's something that's shown right there. So there's tons of operators here, as you can see. And this is an important thing to know because I guess lots of bioinformatics is really just reshaping your data in a way that's useful to you. And this is how you would do that. And then finally, the other really great thing is common usage patterns. So there's going to be lots of tasks that you're going to want to do fairly regularly. So you want to turn one file into 20 files and then process all of them at the same time, or recombine 20 files into one file and aggregate them. this was an invaluable resource to me when I was first learning. So like once you kind of overcome the syntax, then it's kind of puzzling out like, I want to do this, but I don't know which combination of operators to use. And this is really a lifesaver. So I highly recommend those resources. Okay, so now we're gonna just go through some examples so I can show you like structurally how they're very, very similar, and how really all processes are broken down and written in the exact same way. So the first step in my pipeline is this alignment with HiSat2. So this is within like section 2 of the NF core RNA-seq, and you can see it right there. So it's all color matched. And in green are going to be your processes, in orange are going to be channels. So these two are input channels. This is an output channel. This is what I called earlier, the align_BAMs. And this is the script that calls the tool. So if you just copied and pasted this, well, I guess it wouldn't work because of all the environment variable expansions. But this would be essentially how you would just, execute HiSat from an interactive command line with all your little parameters with the correct paths. So that's how that works. Okay, so another example. When I'm using Picard to mark duplicates. So here, yeah, I do talk about it later. Okay, so here you can see, again, I've specified the process out here. And then this is my input channel, which is a BAM. And this was read in from the align BAMs before. And then this is an output, which is this duplicate marked BAM. And you can see this is actually a specified output of my workflow. And again, inside script is the actual command with the tool and the parameters that it takes in order to produce all of those. And this matches this because that's the only way Nextflow will know that this is what you want.
So is script on the syntax?
No. So in here, I think you don't even have to call script. There's other like syntactical sugar things that will let Nextflow know not to parse it as a a bash command line, but you could feed it like an R script or something.
Yeah, or like I'm seeing people write Python code.
Yeah, so you could insert like Python, and then I think you just have to change what this says, so it doesn't say script. It'll say something else to specify that it is Python. Yeah. But yeah, if you want to be really organized and you want to have a source directory with all your scripts and it's like easy to maintain and things like that, you can just literally in here just call that script with your inputs and then let the script handle all the parsing. So for example, if you like already wrote a ton of analyses scripts in R, and you can just modify them to take inputs and then put it into a source directory and then point Nextflow to that script and then feed it the necessary inputs.
Nextflow is called that script.
Yes.
Or Nextflow is called that script, called Python script. So you can have many layers right here.
Yeah.
Script is just executing that.
Yeah. So I think there's different ones for this that don't end up, you don't have to literally give it like sh and then like path to a .sh file. I think you can actually feed it like a script or like an actual path to something. I believe. Yeah. Yeah. Mm-hmm.
You mark the band orange in that channels, and how does this process determine that's a channel? Because, for example, the first pass is a band, and the second pass is an index file. The first is channel, the second is not. And how do they?
Oh, sorry. So these are all channels. I just didn't want to get them like all. Yeah. Yeah. So yeah, these are channels.
Okay, so this kind of channels are maybe years for the process. That's
no. So this output is being declared right here. So you're seeing it be declared. So it's this emit call that names it. Yeah. Yeah. So this is how you can chain the output of one file into the input, or the output of one process into the input of another process, is with these emit calls. And there's other ways to do it. but this is a very explicit way of doing it.
Okay.
So now this channel is called FLG BAMs.
Yes.
And then your next tool is going to take FLG BAMs as input.
Yeah.
Calculate that.
Yeah.
Nice.
And you can see it being used here because I need a BAM for quants and I need a BAM for exon quants.
Yeah.
So you can see how like it's really easy to process the same BAMs in different ways.
Okay, but all of the same channels.
Yeah. So these are all named channels. Yeah. It's coming together. Okay. So one more example. So summarizing coverage. So this is where, yeah, we're making that big wig file. And so same thing, the input. So that's that BAM that we talked about. And then here in the output, it's just writing, or it's looking for this underscore coverage.bw file, and that's made right here. And again, this is just a regular old call to BAM coverage, as long as it's in your path, and it'll execute.
Let's say one of these operations, instead of relying on the nice singularity intervals, pass into something like a module on the Sockeye system. Would I call module load in the script chunk here, or would I add module load to the big process?
I don't know what the correct answer is, but if I was to write it, I would do it right here.
Yeah.
I would do it like inside the script. So I would module load before I did this, because it would do it like in the process that's going to call the tool.
Yeah.
Whereas if you module load in your, like in the Q sub, I don't know if it would still be loaded.
No, I mean in your config, your nf.config.
Oh yeah, you can't module load in there. Yeah. Yeah.
So the only place that it would happen to be.
Yes. Yeah. 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 I think this would be the most direct way to do it because it's like right before the tool is being called. But I don't know if that's got like some kind of penalty with like memory, or, you know, if you don't expect it and you didn't allocate enough. I don't know how that would work. Or if it's just like changing your path.
So this kind of, and config cannot be model. If you want to do it in the script.
Yeah. Yeah. Like somewhere where, yeah, like it's being interpreted as a shell command because it is like module load is like a library. Yeah. 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 I think I do have one exception to that, which is it is inside the config, which is why people may be a little bit confused. So in this config, I do a module load. And that is for a specific reason. So yeah, there is one module load here, and it is because every single instance of a job spin up is going to need singularity. So that's why I do a before the script even runs to module load singularity, because there's no way to do it afterwards because it would have failed, right?
That was my follow-up question with singularity, because that's the one running.
Yeah. All your tools.
Images.
Yeah.
For every single tool.
Yeah.
So you can put it there, and this before script means so you only have a single process. Right?
Yeah. So this is, if it's just process, it's like a generic process.
All process.
Yeah.
But you could also have a process with the before script or BAM coverage, and you could put module load BAM coverage.
Yeah, I guess you could. Yeah. So yeah, I mentioned this earlier where like, oh, you wanted to change the memory allocation for like a specific process in NF core. You would do that in here, but you would put the entire name of that process, like fully qualified process name.
Yeah.
Then you would do another like semicolon brace. And then inside you would specify the memory. And that's how you would change it for a specific process. But if it's here at the top, it would be for generic. So yeah, I guess you could call a process by name and then specify a before script for that. Yeah.
And so that could be conda activate or
Exactly. Yeah.
module load.
Yeah. Well, for conda activates, it would be something different. I don't think you would use the before script call. They have other things that are actually like
Yeah.
native for that. Yeah.
But
Yeah.
like a hacky way to do it.
Yes, you could. Yeah, exactly. Yeah. Okay. All right, so that's summarized coverage. Okay. So the last thing is cores in memory. So the first time that you try to write a workflow and you try to get it to dispatch jobs, and you don't specify cores in memory, you're going to do what I did, which is you're going to get a single process to consume an entire node, and then nothing will run. It'll be very slow because it can only dispatch like n number of nodes. So the way that you're supposed to do it is you need to specify explicitly for every single process exactly how many cores and how much memory you expect it to need. And one way you can do that is by explicitly stating the CPUs and the memory at the top of every single process. So for example, inside here, you could write, cores 8 or like cores like live coding. It'd be like cores 8 like that instead of the label, right? So the reason that you might want to do something like label is because it's for like redundancy. So it's like one of those code smells that you don't want, where if you just have, you specify CPUs one in like a bunch of different processes, but then you decide that, oh, like all of the processes that call feature counts actually need more cores, you'd have to go in and change them for each one, and you forget, then like you've got things that are misconfigured. So if you use labels, you can specify just inside the configuration file. So this is inside the config. You can specify how many CPUs and how much memory to use if I label a file, or if I label a process with this name. So here, this is in my config. And if I use this to say this calculate coverage is labeled with 8 cores. So that means that when every time Nextflow spins up a calculate coverage process, it should use 8 CPUs and 32 gigs of memory.
You could also do, so when you talk about adding like with name, that would be another way to do it.
Yes, correct.
With name be the same nested code chunk under process?
Yeah. Yeah, it's the exact same. So yeah, you can do with name. And I think like even when you use with name, you could use regular expressions to capture processes. Yeah, so there's like a lot of power there. So if you have a clever naming scheme for your processes, you could actually configure them like in a like sweeping way.
So it was like with name sample star.
Yeah.
And you add sample sort and sample view.
Exactly.
You would then apply that CPU and memory chunk to
all SAM tool processes. Yeah, it's pretty great.
I have
Mhm.
a question here. For example, in the QCell, and we already applied maybe, for example, to switch to gigabyte memory.
Mhm.
And once when, of course, we will start to use all this memory. But if, for example, in something before the start, for example, Python to something like that, and it only needs 4 gigabytes. But in QSub, we already apply 32. So in the core one, we use 4, and the rest of today is just as there.
Oh, you mean like
Because in the QSub,
No. So I think what you're missing is that the Q sub you run, and when you type Q sub, that's just to start next. All of these jobs, like for 1 CPU, 4 gigs of RAM, 8 CPU, 32 gigs of RAM, that Nextflow process is launching Q subs itself. So, and it's launching those Q subs.
oh,
with
each
these,
of
with,
this core one have the QSub for the 1 core, 1 CPU and 4 gigabyte, and another core one launch another 1 CPU. And
yeah. So
Yeah.
can you show us your whole workflow again? Yeah, so in his, and we get down to your workflow. So this workflow, right?
Yeah.
It's gonna first submit a job for every channel that needs to align fast.
Yeah.
So it submits, if there's four samples,
Yeah.
it submits 4 jobs.
4 times.
Each one of those jobs
Yeah.
is gonna have a certain amount of resources, and we
Mhm.
just went over how you allocate it. Then the next step, flag duplicates,
Yeah,
when the best user are aligned,
Yeah.
that job's gonna end.
Yeah.
Data will get to where it needs to go, and then the flag duplicates is gonna launch another job.
oh, that job only very small,
Very little.
leave very little resources, so it can get the resources pretty soon.
Exactly,
Get
and-
one.
Yeah, and then maybe if there was something bigger downstream,
Okay.
then it would launch a bigger job for the next. So
Okay.
this workflow is launching
Multiple
4
things.
jobs, yeah, 4 jobs first, then another 4 jobs, then another 4 jobs, and another 4 jobs, and another 4 jobs.
And each of the 4 drops are required different resources, so you have the different stuff based on the core one.
Exactly, that's what he was showing.
Yeah.
Okay, I see.
Yeah, yeah,
Okay,
yeah.
okay. Thank you.
Great.
Thank you.
Thanks, Phil. Okay, so this is like the last kind of wrinkle in Nextflow. So this is the kind of thing that was not very intuitive to me, having written like other like SnakeMake workflows and things. So in SnakeMake, I guess it's kind of an aside, but you would define outputs, right? And then it'll back calculate how to make those outputs based on the processes you have, right? In Nextflow, it's forward calculating. So based on the inputs that you specify, as long as you populate channels that will be ingested by something, it will just take the channels and it'll continuously spin out processes until the channels are emptied. And then those channels that now have things in them, it'll look for processes that can consume those channels, and it'll keep doing that. So it'll process all of your channels until there's no more processing to do. So the problem with this is that it has no idea when something is done and that's actually what you want. So the way to get around that in Nextflow is you have to specify when something is final. So you know that the BAM that I've produced is actually a BAM that I want to see, and I don't want to dig into work and then go find a specific hash to like find that file, because that's where it would live otherwise. You would have to specify a publish dir parameter at the top of that process that's doing the processing that's producing the output that you want. Okay, so in this example, we're doing quantifying gene counts, and here I'm producing this underscore gene.counts file, and I specify to publish dir. So what this will do is it'll grab, well, this is a parameter that's inside my config, and this is the directory that I'm publishing everything to. So it's just exposed to your config, which is something that I chose to do because it made it convenient for me. And then you can specify the type of publish. So Nextflow is an interesting thing where every time you spin up a Nextflow, you attempt to execute a Nextflow workflow, it's just going to find more space inside that hash directory to work in. So it's always going to like make new hashes, make new directories and all this stuff. So that directory will bloat very quickly. So there are all kinds of commands inside the documentation to like get in and like excise a specific run. That's why like when you run Nextflow, you get this really cute name. And they're all like, all the runs are named. And that's because you can use that as a tag to get in and be like, delete this run, it failed, or like resume this specific run. But the problem with that is if you are troubleshooting and you're kind of, just trying to like smash your head against this thing and you're running it over and over and over again, it's like failing and failing and failing, then all these intermediate files are going to fill in your work and it's going to get really big. So the default way that Nextflow publishes outputs is with a symlink. So the symlink will point deep into the work directory. And what this means is if for whatever reason you're like, oh, I've like had too many failed jobs, I need to delete the entire work directory. You think you've published your outputs, but you haven't. So if you delete the work directory, it's just going to now symlink into nothing. So your outputs are gone. Okay. So the way that you should do this is with a publish dir call, and you specify mode copy so that when the file is created, it will actually do a hard copy of the file out into your published directory. And even if you lose the work directory or you move it or for whatever reason it's gone, you actually have the outputs from this process. Yeah.
So in this case, you have only one output for this process.
Mhm.
But if you have multiple outputs, so you specify different publish directories, parameters the different outputs?
So you will need to make them unique, I believe. So they can't be named the same thing. That's why I've been like tracking sample ID through all of the processes, and they're all paired to the files. So that here it's going to parse this to be the sample ID that is the input from this tuple. It's the first value in the tuple, which is going to be the sample ID. And this came from the BAM, and that, you know, originally came in the BAM from the FASTQs. And that was from the sample sheet that I fed it, right? So it's tracked it all the way down here so that I can create a unique identifier for these gene counts for this library or the sample.
Yeah, no, I think that the question is like when you have this published there, is for it to copy the output gene counts.
Yeah.
From the work directory to the output directory for these published directory.
Yeah. Yeah.
But how do you specify, like if you had multiple outputs, not only one file of these gene counts, but you had other outputs, how would you specify like additional publishing directories for those other outputs? And how does it know this publishing directory is for this output and this is for the other output?
I don't know if you can do that actually.
Better practice would probably do break that into multiple.
Yeah.
processes.
Wait, every sorry if you said this before, I know, but each process only has nodes. They can have more than one output.
Yeah, you can produce multiple outputs. So yeah, they would. So in that specific configuration, this would all come out to the same directory. So as long as like all the outputs will be written to this same directory. I don't know if it's possible for like, you know, if you have like 3 outputs to say like the first one should go in this directory and the second one should go in a separate directory. Yeah, it will print everything, I think.
If I may, you can specify that you use so in the output, you put the path, which define the file, and then you do comma emit equal, and you give a name to that sort of file or group of file if you output a tuple. And then you can use that emit in the published here to have them in different places. Because I have a pipeline that outputs, part of them are BAM files and part of them are QC, so quality control files, and I output them in different folders. And using the emit option, it's very straightforward.
Okay, yeah, that's really good to know. Yeah, so I guess emit is more powerful than just creating more channels. Yeah, that's really cool. I did not know that. Thanks, Alen. Okay.
No one ever knows everything.
No one ever knows everything.
No one ever knows everything.
Especially with Nextflow, I always learn new things, and I look at other people's pipeline and I'm like, what is that? What does that do? Can I use this? So yeah. I learned things today, so thanks.
Yeah. Okay. So back to the config. So just like any other workflow, I've exposed some parameters inside my workflow to make it as flexible as I need it to be. And again, just with any workflow, your parameters come in 2 flavors. So you've got those Nextflow execution parameters, so things for submitting to PBS Pro, all of those things. Those are still the same. But then there's also going to be workflow specific parameters, and those are things that I know I set up so that the workflow can be flexible, right? So to execute on PBS Pro is exactly the same because this is a Sockeye specific thing. So I specify the executor, I specify the queue, and then my quota. But in terms of the parameters that are read, those things are going to be different because I don't have all the same setups that NF-core RNA-seq has. So for one thing, we specified the genome that RNA-seq from NF-core was going to align against. So here you see we submitted that string, and that's how it knew, like, inside the iGenomes directory to look for the build 38 reference and for the build 38 star index and for the build 38 gene annotations and all of those things. But for me, I didn't expose that because I hard coded it, because the data that I'm adding these, processed RNA-seqs to are also from build 38, and I don't have any need to make it flexible. So none of that code exists. So those parameters they don't exist because they're not interpreted anywhere. right? Alternatively, NF core RNA-seq is set up to take a sample sheet. So the sample sheet has paths or fully qualified paths to the paired end reads. So I didn't do that because, well, I was lazy. And instead, I coded it into the workflow so that it would parse the pairs as necessary. And I thought this would be the easier way instead of having to write a sample sheet by hand. So here I used a FASTQ directory and I pointed it there. And then using logic inside the workflow, I find the pairs and then process them one by one. So again, this is like a preference thing, or it's like however you want to run your workflow. This is something that you could do. And then in the future, because I know I'll be processing other FASTQs, all I have to do is point this to another directory where I've dumped more FASTQ pairs and it'll just work. Okay, so fundamentally, they're both like RNA-seq pre-processing workflows, right? But they're, different and similar in very important ways. So obviously the NF core RNA-seq workflow is very flexible. It's broadly applicable. It's peer-reviewed. It's community developed. The people who work on it are up to date with literature, up to date with tools. So it's always going to be cutting edge best practice. My mini RNA-seq workflow was tailor-made for a specific job, for a specific application. And it's only configured for the things that I need it to. And it will probably never be maintained again. And will probably never be ran. But because it is a workflow, if I wanted to go back and take a look at it, all the config will be there. All of the code, the logic will be there. So I can always figure out how I did something in the future, because that's always going to happen to you. But importantly, both of these, because they're written in Nextflow, they can be scheduled onto a cluster. They can be configured to run many samples in parallel. Those are like important similarities, and it's kind of the reason that you're using Nextflow in the first place. Great. So in conclusion, Nextflow is a super powerful tool for any kind of workflow development. And NF core is going to be your best friend if you're, still learning how to use Nextflow, or really even if you're really experienced. It's just sometimes not worth the trouble of writing up an entire workflow when something that was made by people who are very smart and very capable is readily available. So it's something that you can always check in on if you have an analysis that needs to be run. And I don't think anybody here is going to be confident writing their own Nextflow pipeline right now, but I think with a little bit of reading and practice, hopefully I've given you a really solid foundation for understanding like the anatomy of a Nextflow workflow. And hopefully that's what I can give you today. So yeah, that's it. Use the link to give me some feedback. I don't think I've ever taught a workshop before, so I'm curious to see what people say. But thanks. Mm-hmm. Yeah.
My point is about resuming a job with Nextflow and how it differs compared to Snake, right? How a Snake may kind of back forwards, like it knows the inputs it needs from the previous output, but with this you work with channels to kind of do that. So we're talking about consuming channels. That wasn't very clear to me in the sense that if workflow files, how do you set it up so that it knows where to resume the work? How does it know?
Yeah. So this is part of, from my understanding, it's part of that whole like hashing structure in the work directory. So it knows like in a specific folder, these are the outputs from a specific process, and it knows what parameters it fed that process to create those outputs. So even though like, conceptually they're channels, like these are real files that exist inside work. So all the channel is like keeping track of like which hash directories contain which files that should be in a channel. So then when, all of those channels are populated and a process could be run, it actually just symlinks all of the necessary inputs from all over the place in work into a new hash working directory. And then it just runs like whatever you wrote in script in that directory as is. Yeah. Yeah. And this is like one of those advantages over SnakeMake. So like one of the main headaches I had with writing SnakeMake is like you always have to worry about like file name conflicts and things like that, because it uses very strictly like file names in order to figure out which inputs and which outputs match. So you're always thinking about like, oh my gosh, like how do I like encode this into the like intermediate file name so that it'll know, this file is different than this file. And it was just a lot of like overhead. So I found channels to be really, really intuitive, because you literally, you hard coded in the workflow to be like, this is an output and this output is fed to this process as an input. Yeah. Yeah.
Any other questions?